Ladies and gentlemen, I would like to tell you a little bit about how you can implement and scale up your research and really have it like an industry at the end. I'm a scientific director in Clariter. I have a PhD in chemical engineering, and I joined Clariter 13 years ago. So it's a long journey, and I could observe what happens with the research from the very beginning until the real implementation. So when we start our research, no matter what in what area of interest, the first we are thinking of is what is the problem we would like to solve. In case of Clariter technology, there were a couple of problems we wanted to approach. First was to reduce plastic waste, amount of plastic waste. Actually, when company was started, there was not much attention to that issue. At that time, the most popular way was to landfill or to incinerate plastic waste, which we already know right now that is not correct solution. But the inventor of the technology was a really visionary who predicted that this issue will increase because he knew that plastic has a very long lifetime and we are going to use more and more plastic. So the issue of plastic waste will increase with the time. Another problem that requires and still requires to look for proper solutions is our dependency on crude oil. We can imagine that fuels is not the only product of crude processing. There are also other products. So although we look for biofuels and different alternatives for fuels, we should look for also alternatives for other crude-based products. Of course, we should also empower local economies to enable new industries to grow, and at the end, to clean our planet, because we can reduce the amount of waste we currently produce, but also we should think of all the waste that is stored currently in existing landfills. So I would refer now to Europe and data regarding Europe, because I don't think it will be too big exaggeration if I would assume that Europe is actually really highly advanced in dealing with waste and mainly targeting plastic waste. So what is currently happening in Europe with post-consumer plastic waste? Well, it is collected around almost 30 megatons per year, and then it is sorted out. But quite interesting enough is what's happening afterwards. So only 9.4 million tons per year is sent to recycling, and at the end in Europe only slightly above 4 million tons per year is used as a recyclates in the industry. Still, huge amount, actually majority of the collected plastic waste is incinerated, but we need to remember that incineration, even with energy recovery, is not giving 100% recovery of the energy. Only up to roughly 30% of energy that is included in the plastic is recovered via this process. But also significant amount is landfilled. There is a new technologies or new ideas how to deal with plastic waste, which is chemical recycling, but currently it is really, really minority. If we look at the composition of plastic waste in Europe, it is very difficult to find the data about that. So we looked at the production rates, right? So if we would look at the demand in Europe in terms of type of resin, in terms of plastics, we would easily see that the majority is, or the big stream are polyolefins, polyethylene and polypropylene, different types, which is here like 40%, right? So, and 40-50%. So this is the majority in demand. If we look at the applications of plastic, actually these are the plastics that are most commonly used in packaging or single-use plastics. So they have very short lifetime and they're very quickly thrown away. Because if we think of PVC, for example, this plastic has a lot of applications in building industries, like windows or carpets. And then, of course, the lifetime of those items is much longer. And this kind of waste is not ending up in municipal solid waste streams. So the target would be to look at the polyolefinic materials that are used. So the problem to be solved is to how we can deal with plastic and mainly polyolefinic waste. So of course, this next step is to, when we identify the problem, the next step is to look what are the current existing solutions and what new concepts we can think of. So of course, currently looking on this left-hand side triangle, we can say that the most desirable is to reduce the amount of plastic, right? To make thinner packaging or to replace plastic with different materials. But if we think of last 2 years when the COVID pandemic appeared and we used a lot of single-use items like gloves, like masks, that are all of them are based on different types of polymers. If we think of wrapping the food, definitely it is very difficult at this moment of time, at least, to reduce very significantly the amount of plastic we produce and we use. Reuse is, again, in many applications is very difficult. Again, looking on single-use plastics in food packaging, it's quite difficult to imagine how we can reuse food wrapping or gloves that we use to protect ourselves from the virus. Landfilling definitely is not a solution because we have a deposit of plastic in some areas. We have microplastic release to the environment. Of course, this is the less desirable. Energy recovery, it is kind of solution. This is kind of utilization of plastic waste. But as I mentioned, it is up to 30%. So still we are losing the potential that we have in the plastic, but also we release CO2. So definitely we should focus on the recycling. And currently there are two types of recycling processes. One is the mechanical plastic to plastic recycling, and second one, relatively new branch, is chemical recycling. If we think of those two types of processes, mechanical recycling is relatively easy. We have kind of products, then we have when we end up using them, they are shredded, washed, then mechanically recycled, like remelted, proper modifiers and pigments are added, so we have new products. And of course, this kind of loop we cannot use indefinitely, because plastics reduce their mechanical properties, and actually at the end we can see that we downcycle the material instead of recycle. So chemical recycling is potentially the solution, because we can use products, we can of course shred, prepare, and then through chemical process or proper chemical processes we could create new polymers or new chemicals or new products that are then used again. And in this case, we may think of many other cycles, or to approach new industries where those chemicals, for example, can be used. So what is the research that was the base of Clariter technology? Actually, the inventor of Clariter was Professor Andrzej Belicki, a well-known Polish chemist, who ran his research in Scientific Institute, and in 2002 he applied for a patent that was later on granted in Poland, in US, in Israel, also in European countries. And in 2003, a company called Belicki Laboratories was created. Just for you to know, in 2002, when Professor applied for the patent, he was of age 86. So he was 86 years old when he applied for the patent that was the basis of the current technology. So as I might say, there is a lot of time for us as well. And following that, the creation of the company, the pilot plant was created, because of course the beginning are the lab scale tests, but then you need to scale up. Of course, you cannot scale up new processes or new technologies, especially in chemistry, from the bench lab scale immediately to industrial. It's not IT when the scale up is easy. You need to make it step by step. So as a next step, the pilot plant was built. We started construction of the pilot plant in 2005. In 2006, we may say that the first version of pilot plant was created. It has and still it has capacity of 6 kilograms per hour, and all of it was privately sponsored. This is also quite interesting and unique about Clariter, that it was not a spin-off of any university, but it was really privately sponsored from the very beginning. So in those pictures, you can see how the pilot plant was changed over the years. We built a couple of hydrogenation and hydrotreating reactors to test different catalysts. We have a couple of distillation columns. The cracking reactor, which is the first step of the process, was reconstructed many times. So it took us a lot of time and effort to really check all the research that professor done in lab. We also built our own lab. Actually, this is 2018, and nowadays we have even more modern laboratory in our pilot plant. Everything is owned by us. So we have GCMS, we have GCFID, we have GC4 SIMDist, and additionally, any other equipment for physical-chemical properties of our products. We cooperate with universities, for example, Silesian University of Technology in Poland, but also in Wrocław, in Warsaw. We cooperate with scientific and research institutes in Poland. So this, and to really scale up this technology, it took a lot of effort, but also it required a lot of cooperation between different institutions and different scientists. So of course, the natural question is, what is the solution? What we really achieved over this time? So in our unique technology, we take mix of polyolefin waste, all types of polyethylenes, polypropylenes. We accept some level of polystyrene. And what makes it different from mechanical recycling is that we accept the lowest grade of those plastics. So whatever rejects from mechanical recycling are there, we are happy to take it. Whatever types of polyethylenes, for example, that are not mechanically recyclable, like cross-linked polyethylene or ultra-high molecular weight polyethylene, that cannot be mechanically recycled, and there is a waste made of that, we are happy to take this. And the first step of the process is thermal cracking. We don't use any catalysts at this moment in this process. We tested a couple of them, but they didn't fulfill our requirements. And you may say that, well, pyrolysis is well known for many years, right? But what we do it continuously. And this is quite unique, because to find the proper solution for the process, not only from chemical point of view, but also from engineering point of view and from mechanical point of view, is a challenge, especially if you target a proper range of products at the end. And what is really unique about our process is that this mixture of hydrocarbons is directly fed to hydrotreating section. It really took us a long time to find the proper catalyst, the proper parameters, the proper way how to deal with all the contaminants, because from plastic waste, we can have heteroatom impurities like sulfur, nitrogen, chlorine, oxygen, but also we have a lot of olefins that are created during the cracking. We have also aromatics, and we treat all of them with hydrogen. So at the end, after separation, we are getting a very pure hydrocarbon stream, which is divided into 3 families or groups of products. And the products also are unique, because according to our best knowledge, currently no one is doing what we do. Although there are many chemical recycling technologies that appeared over the years, because since 2003, it really took us a long journey to get to the point we are right now. And on the way, there were many companies that appeared or disappeared, because at the beginning, for example, the idea was to make fuels from plastic waste. This is not our target. Our solvents, aliphatic solvents, our white oils and our paraffin waxes are of the top quality. So all the impurities are removed and we fulfill FDA quality. So this kind of products can be used in cosmetic industry or in as a lubricants in food industry. And thanks to this unique purity, we have quite unique value proposition. We do something new because we are taking plastic that nobody wants. That, I mean, mechanical recycling doesn't want it. Incinerators want it, but we don't want to send it to incinerator. So, and we are taking this plastic and we are making products that are really you can find in your daily life. Just to give you an example, our products were used in formulation of degreasers, in formulations of inks, in formulation of wax emulsions for paper packaging or wood treatment. It was used in shoe polish, car wax, leather treatment products. So many different products where you can find hydrocarbons. And it can be also potentially used in cosmetics. So it is totally new approach because we offer for the producers that we can take plastic packaging and transform it into the ingredients in their final goods. So they can prove that they have recycled packaging, for example, via mechanical recycling. So they can have from one side this kind of recycled content in their product, but also they can have recycled material in their inside the packaging in their product. So actually, what we do, we upcycle plastic waste into new hydrocarbons and new hydrocarbon-based products. Let's fast forward that in 10 years from now, for example, we move from we don't use plastic anymore. We don't use plastic or crude-based plastic for packaging because we find beautiful bio-based plastics or something totally different to make packaging. Still, we have those plastics that are in the landfills, and still we need hydrocarbon-based products. For example, to wax our new electrical car or to have a lubrication for windmills. And Clariter offers this solution for the industry. What is also interesting that we didn't end up with the pilot plant only. We built first industrial scale plant in South Africa, in East London, with the capacity of 1,000 tons per annum. It is small. It is still kind of demonstration plant if you compare us to big petrochemical processes. Of course, no comparison to refineries or petchem plants. But from chemical recycling point of view, it is already industrial scale. That's why, but we treat it as a demonstration plant, kind of intermediate step. It is also, this is proof of concept where continuously from one side we feed plastic waste and at the end we are getting products, but also training center and also gathering data for next step. And what is the current status? So we have 6 families of patents that are already granted in many international jurisdictions, including Poland, Israel, US, and Europe. We invested actually almost 40 million euro in R&D, and majority of that was private money. So it was mainly privately sponsored. We also got confirmation from European Chemical Agency that our products, our final products, are exactly the same like the products that are already registered in Europe. So there is no limits for REACH registration. And it also proves that our products, although coming from plastic waste, they are real alternatives for crude-based products. And we are rolling out. We are currently working on 3 projects, 60,000 ton per annum facilities, 2 in Europe and 1 in Israel. So I think it is quite interesting journey, although it took us a lot of time to get to this point, and we are still on the road. It's not end of the story of Clariter, but I guess it's quite unique because not quite often you see totally new chemical industry appearing and being part of that. If you have any questions, of course, please, this is the time. And if you think of any questions further, just feel free to contact me. Thank you.
Thank you.